the equipment we'll be using. Here we have an oxyacetylene torch setup. These bottles come in different sizes, and typically oxygen bottles are painted green and acetylene is painted black. Even though acetylene is highly flammable, oxygen bottles are by far the more dangerous. This is a high pressure bottle filled to over 2,000 pounds per square inch. If the valve is damaged or broken, this bottle is out of here like a rocket, and anything that's in front of it is gone too. You need to protect this valve, so whenever this bottle is not in use and the regulator's off, or you intend to move the bottle, you need to use the protective valve cover, even when the bottle's empty. Acetylene gas is unstable at pressures over 15 pounds per square inch, so acetone is used inside the bottle as a stabilizer. As the acetylene is being filled, it's absorbed by the acetone, and these bottles need to be straight up and down when in use. Now, whether these bottles are in a portable bottle cart or up against the wall, they need to be chained up securely. This is real important. You don't want to be able to pull them over with the hoses or knock them over. Also, these bottles are regulated by the Department of Transportation and need to be straight up and down and chained securely when transported. This is the oxygen regulator, and before you mount the regulators, stand behind the valve opening and crack the valve to blow out any dirt or moisture. The high pressure gauge reads up to 4,000 pounds per square inch and measures the pressure inside the bottle. The low pressure gauge measures the working pressure coming out of the regulator, and this is a regulator adjuster. Screwed in or clockwise increases the pressure, and screwed out decreases the pressure. The high pressure gauge on the acetylene regulator only reads up to 400 pounds per square inch, and here again that measures the pressure inside the bottle. The working pressure gauge is marked at 15 pounds. Remember, acetylene is unstable at pressures over 15 pounds. The pressure adjuster is the same, screwed in to increase the pressure, screwed out to decrease the pressure. Also, the fittings on the fuel gas regulator are notched to indicate left-handed thread. All the fittings on the fuel gas side of this equipment are notched with left-handed threads to avoid mixing the equipment and getting an oxy fuel gas mixture where you don't expect it. Generally, you'll have a red hose for acetylene and a green hose for oxygen. 1/4 inch is a standard hose size for normal cutting situations, and a section of 3/16 hose is often added at the torch end. The smaller hose is a little more flexible and easier to deal with in awkward situations. If you cut or burn these hoses, you can get repair parts at a welding supply store, and most have a crimping tool they'll let you use to install the new ferrules. Right here, I've installed flashback protectors. In case fire does head back down the torch, these stop it right here and keep it out of the hoses and regulators. This is a standard torch body. You have the main oxygen and acetylene valves. These are stainless ball seat valves, so when you close these, don't over tighten them. If you reef down on these, you may ruin the seats and the valves will leak. We'll be using a regular 90-degree cutting head. They also come with a head at a 45-degree angle, which I've used for beveling heavy steel, and they come straight for special applications. For general use, the 90-degree cutting head is the most convenient. This is the oxygen adjustment valve for the preheat flames, and here's the oxygen cutting jet lever. Now, the oxygen and acetylene aren't mixed in the torch body, they're mixed up here in the head. So there's 2 O-rings in this connection to seal the passageways. When you install the cutting head, just hand tighten the nut. Don't use a wrench or you can crush the O-rings, causing this connection to leak. And I like to line up the cutting head with the torch body valves. It's a little more convenient to make the adjustments. Now, all the equipment we've looked at so far can be used with either acetylene or propane. We set up on an acetylene bottle, but the same fuel gas regulator can be used on a common propane tank. The only piece of equipment that's different, depending on the fuel gas you use, is the cutting tip. An acetylene cutting tip is a 1-piece tip. There's 4 to 6 small orifices around the outside for the preheat flames, and the larger center hole is the oxygen cutting jet orifice. A cutting tip used with propane is a two-piece tip. The grooves on the inner piece are for the preheat flames. Because the rate of burn for propane is slower, you need a bit more preheat flame. Now, these tips come in different sizes, so let's take a look at a cutting chart. The commonly used cutting tips start at triple aught for metals an eighth of an inch thick up to a number 3